Hi, so now we're going to talk a little bit about digit problems. You're probably not going to be talking about this very much in your class. Maybe you will, maybe you won't. It is in your textbook, incidentally. There's a note up at the top of the page on the Blackboard site with exactly the exact page numbers that they're on. So you should maybe check them out there too. But we're going to be dividing this video up into two parts. The first part, I just want to talk about the general idea of digit problems, how they work, what they look like, and that sort of thing. And then in the next video, part two, we'll do an actual example. You do have a couple digit problems on your homework assignment, numbers 9 and 11, and so if you're having a little bit of trouble with them, hopefully these two videos will help you out. We won't be doing either of those questions, those are for you to practice on, but we'll do some similar ones so you can hopefully do okay with them. So, to understand the idea of a digit problem, we have to first remind ourselves what a digit is. And a digit is a number that makes up a larger number. So like 13,459, for example. There's different digits. There's 5 different numbers that make up this number. And each digit is in a place value. There's the units place, there's the tens place, there's the hundreds place, there's the thousands, there's the 10,000s and 100,000s and millions and so on and so on. So each of these place values we fill in with a number from 0 to 9, and that creates the number, the full size number that we're looking at. So your problems on this assignment only deal with 2-digit problems, so I'll get rid of that business. So we just have the 59 with the tens and the units place. Now, a lot of digit problems involve the digits individually. In fact, that's the nature of digit problems. And so we need a way of describing the tens and units digit separately from each other. So 5 here is the tens digit, 9 is the units digit, and so usually when you have a digits problem, there might be, and again, you can look at your paper there, but there will be some part of it say that like the sum of the digits is, in this case, 14, and maybe the units digit is 4 more than the tens digit. Or the number itself is, in this case, 9 more than 10 times the tens digit, or something to that effect. So we need a way of describing the tens and units digit, a variable to call them. And I like to use actual letters that kind of model what they represent. And so I'm going to say I'll let 10, or let t, equal the tens digit. And we'll let u equal the units digit. Incidentally, this is why I use u and units instead of ones place, because if that was a 0, or if that was an O, it would look like a 0. So anyway, if those are the let statements that I go with, for this particular number, I'd have that t is equal to 5 and u is equal to 9. So that's a way that we can kind of talk about the tens and units place digits of a 2-digit number like this. Now we need a way of actually getting the number from this, because we can't really, for example, just do tu. T is the tens digit, u is the units digit, and if we have numbers, we could just put them next to each other and make 59. But if I write this looks more like it's t times u. So we really can't do tu like this. We can't just put them next to each other, because then it looks like multiplication. So that's not going to work. In order to figure out how we actually describe the value of the number, the actual number that is made up by these tens and ones digits, tens and units digit, I should say, is to think about the expanded form of this number. And it's probably something you haven't done since like 2nd or 3rd grade, maybe even since before then. But it's the idea that the number 59 is composed of 5 tens and 9 ones. We could write the expanded form of this as 5 times 10 plus 9 times 1. And you could argue that you don't really need that times 1 there, but that's kind of the idea. So when we have the number tu, which is the 2-digit number here, what we're really saying is that t is the tens digit, so we have t times 10, and then in this case 9 is the units digit, in this case u is the units digit, so it would be plus u. So to rearrange this a little bit, the number we can describe as 10t plus u. Because if it was 10 times 5 is t is 5 and u is 9, then we get 10 times 5 plus 9, so 50 plus 9, which is 59. So this is a way that we can write the number, the actual number that the t and u give us as the 2-digit number in question. The last part of this is that you might have already noticed on number 11 that it talks about switching the order of the numbers, swapping the numbers or reversing the numbers, the digits. So if we reverse the digits here, I get 95, and which would be 9 times 10 plus 5. Now you may have an idea of how this is going to end up working, and hopefully you do. If you do, then great. But keep in mind, we had TU, which is now becoming UT. So what was the units digit is now the tens digit. What was the tens digit is now the units digit, or it's in the units digits spot. It's still the tens digit of the original number, but they've swapped orders. So really what we have then is that the reversed number is now 10u plus t. So we have the original number, 10t plus u, where t is the tens digit and u is the units digit. And we have the reverse number, 10u plus t, where we're just swapping the order of the numbers. And then these two ways of describing the number and then the reversed number, given the t and u's place, that's how we can describe these numbers. So that's the idea. In the next video, we'll go over an example.